Hello everyone. In this tutorial I'm going to briefly cover the conceptual massing environment and the basics of establishing parameters within that environment. And to do that we're going to create a little swoopy roof geometry like this one right here. So to get started, from the splash screen select this new conceptual mass option and you'll be given a choice of only one file type to work with, this mass.rft file. So select that one. Now this mass file looks a lot like a typical family environment except for a few key differences. The most immediate visual difference is that rather than having a white background, there's a bit of a gray gradient. And this is just kind of a visual cue letting you know that you're not in the typical environment. Something else that's unusual is it instantly opens to the perspective view rather than the plan view. And that somewhat explains what the purpose of this environment is for. This is really an environment where you're meant to bring together geometry from other families or to almost sculpt geometry, which is somewhat unlike the typical family environment, which is much more rigid and stiff. So another thing you might notice is if you were to go to the model line, or any of these lines, unlike in a normal family environment, you're not going to get a bunch of options for how to create form. You won't get extrusion, sweep, blend form. You're only getting create form. And if you click on it, you get the choice of solid or void form. This is kind of a black box of geometry creation and can be a bit intimidating at first. But the thing to remember is that all the types of form you can create with this tool are exactly identical to those in the typical family environment. For some reason, they just decided it would be simpler to turn it into one button, though it became quite a bit more confusing in my opinion. Alright, so to get started building something in this environment, you're going to want to establish some very basic reference planes. The reference planes here are what define the position of geometry that you will then link to them. They're like construction planes in Rhino. So a good way to get started developing reference planes is to go to this level 1 here, and I did that by double clicking on it. Click the reference plane option, then the pick lines, which is a tool that allows you to pick a line and it will offset from that line a certain number that you specify. I'm going to choose 20 feet just for simplicity. And I'm going to offset from the already existing center lines in both directions. This creates a square form defined by these lines I've just offset. Now it's important that you offset in both directions from the center and not offset once from the center, then again from a line you created. That's because these center lines have an option checked here, define origin, which makes them permanent and immovable. They will always be exactly where they are as long as you leave this box checked, and I strongly encourage you to do so because things can get really weird if you don't. These lines don't define an origin. They're instead defined by their relationship to the origin, which you can see defined in that dimension right there. Now, when you parameterize a file, what you're basically doing is making it so that instead of being controlled by GUI elements like this push and pull here, it will be defined by a set of numbers which we'll access from this menu. So a good way, or the best way, to start by parameterizing a square from the origin is to equalize its position to the origin. So what I did right here was I made these lines always an equal distance from the origin. That way, regardless of what I build in between these two lines, it will always be centered in the center of my document, which is defined by the two original planes. Now, how I did that was I clicked this Align Dimension button, an outside dimension, an inside dimension and the other outside. Now all this has done is given me their dimensions and some options. You can lock the dimensions so they become immovable, just like how the center origin is locked. You can parameterize them, which I'll get into in a second, or you can equalize them by clicking this EQ button. And now these, just like the others, are equalized from the origin. Now the next step is going to be parameterizing these exterior dimensions. So to do that, go back up to this Align Dimension button. This time, we're only going to click on the two outside dimensions. Now that you have these set, we can begin parameterizing them. And this is the most fundamental principle of the conceptual mass environment and most family environments. To parameterize one of these dimensions, you select it, go up to this label function. Now this is a default parameter that comes with all conceptual mass environments. I don't exactly understand what it does, but I would leave it alone if I were you. Instead, click this Add Parameter key, and then you'll get this new dialog box. We're not going to talk about what shared parameters do, but the internet can tell you if you're curious. We're also not going to go into instance parameters. Again, something the internet can tell you. Instead, we're just going to stick with the fundamental type parameters, and it needs a name. This name will be length because it's the longer of the two dimensions, and we'll make sure that it stays that way. And then this parameter, while we could come up here and give it the same dimension as length and make this a square, instead we'll give it a different dimension of width. Simple enough. Now you may be thinking, well, that's all well and good, but these are still just controlled by dragging. There's not really any difference. And while they can still be controlled by dragging and the parameters do update, there is one key difference, and that is this family types menu. Within here you can see that width and length now show up, and I went to this menu pretty quick, so I'll show you exactly where it is one more time. It's right here, family types. This is a menu that exists within all Revit working environments, and it's integral to any sort of parametric process. Now that we have these parameters set, it's always a good idea to try flexing them, which basically means putting numbers in and seeing if they respond in the actual working environment. So let's make it 50 feet wide by 80 feet long. And everything snapped nicely into place. It seems as though those parameters are working perfectly well. So now click on this button to go back to 3D view, and you'll see the work we've done. Basically what we have are work planes here and here, which are defined by this width, work planes there and there, which are defined by this width, and they're both centered along this origin, which is good. But we're not building two-dimensionally, we're building three-dimensionally. So it's important to also have a height constraint on our geometry. The best way to go about doing that is to switch views to an elevation, and I just always default to north, but you can choose whichever you would like. Then, because you'll notice that this is defined by levels, much as in the typical Revit environment. And we want to create levels to correspond in relation to this level 1, which is consistently located at elevation 0, 0, unless you change it. So to do that, we're going to create two new levels. These will respond to the two different levels at which our geometry in the final product will exist. Now, these are really arbitrary heights, you'll notice, and that's because I'm going to refine them more. But first, I want to parameterize them. So to get started, I'll name them to keep some clarity in my project browser here. This will be the lower roof. And yes, you do want to rename corresponding views. This will be the upper roof. Again, renaming the views. Alright. You'll see that when you select them, they have these dimensions like most files in Revit and can be moved with them. Now, this lower roof, my intention for it is for it to stay exactly where it is. So I'm going to put it into place, which is 15 feet above the ground. I'm going to use the Align Dimension tool to create a hard measurement for its distance from the ground. Then I'm going to click this lock button. Now, this elevation right here, this level, is permanently defined by 15 feet from level 1, which is defined as at 0 feet. These two will stay exactly where they are, regardless of what parameters push and pull on them. Now this roof level, I actually do want to parameterize. So I'm going to go up here and create just one dimension chain for this. Put it right next to the other one, but it is still separate. As you'll notice, they aren't linked together as they were with the plan view equalized dimensions. And here, I'm going to parameterize this by adding a parameter, and I'll call it roof difference, and which is 41 feet right now, which is a pretty dramatic difference in roof elevations. I'm going to take that down to just 15 feet. Which again I accessed through the family types menu. And as you'll see, when I flexed that parameter, everything snapped cleanly into position. So now that we have a nice outline drawn, again you can get back to 3D view by clicking this house button, you'll see that we're basically ready to start geometry. There are going to be grids of points created between these intersection planes, which we're going to use to create reference lines. The reason we're creating reference lines and not model lines is because reference lines continue to exist after they have been used to create a form, whereas model lines become consumed and integral components of the form they create. This gives forms created from model lines much more flexibility than reference line forms, but they're almost impossible to make parametric. You would want to use model lines more if you were importing a conceptual mass into Revit for environmental analysis, whereas you want to use reference lines more for creating scaffolds for geometry that are very specific and that you want to use to place family components, which is what we're going to be doing in this tutorial. So, this is not an ideal environment to draw a reference line. It's not ideal because it's kind of hard to tell exactly where you are. You can set your reference plane and you can see these points, but weird things just tend to happen when you work in this environment. That's not to say I never do it. There are times where it's more appropriate, but this is not one of them. So I'm going to switch over to my level 1 floor plan, mostly just for clarity's sake. Then I'm going to select the type of line I'm going to use, and it's very important that when you do this, you keep a very rigid order. First, you select what type of line of these three you want to use. Then you select which of these drawing types you want to use, and I'm going to draw with lines. Then you select Draw on Face or Draw on Work Plane. This is a very critical part of the drawing process and will determine whether or not your line work follows reference planes or other geometry that it's associated with when those geometry move as their parameters shift. It takes some getting used to the interface before you know exactly which is going to work when, but for this sake, but a good rule of thumb is that if you're drawing on a reference plane, you want to use draw on work plane. And if you're drawing on geometry, you want to use draw on face. Sometimes it won't be like this, which is sometimes a little counterintuitive, but in this case, since this is a pretty simple thing we're making here, it is. So now that you have all of these three settings picked, go to this option, Set Work Plane, and this is the last option before you're ready to get drawing. If you were in the 3D view, it would simply ask you to pick a work plane. It wouldn't come up with a dialog, you would just click one with your mouse. But because we're in a top-down plan view, it doesn't really understand how to draw on any work plane other than the one work plane it's looking at right now, which is this level 1 work plane. So it's going to ask you to pick a plane, and then it's going to give you a list of planes which can see that plane you've chosen. So we're going to go to Pick Plane and start with this very furthest to the bottom. And it's going to say, well, I can't see that plane in a meaningful way from this plan view, but I could see it from either of these. Would you like to work in one of these? And I'm going to choose north just because I always default to north. Going to start left to right. I'll draw one line from this intersection at the bottom here up to this intersection at the top, and you can tell that it understands this is an intersection in two ways. It gives you the purple X and it highlights both of the planes. The X tells you it's an intersection, the highlights tell you what intersection it's looking at. Then I'm going to go down to this intersection, which again has the X and the blue planes. Then I'm going to go back down to the bottom. And then click any other button. You can also hit escape to get out of the line drawing interface. Now you'll see these lines have turned out quite nicely. There they are in 3D, oriented neatly on that work plane, and they line up perfectly with these. Now it's always a good idea to flex work planes before moving forward, just to make sure that this whole geometry drawing that we've done so far has worked. So I'm going to change every one of my work planes and see if it's capable of jumping into the new position. To do this, you can change the dimensions and hit OK, which will apply them to your geometry and close this interface, or you can hit Apply. When you hit Apply, everything changes its position, and as you can see, everything did seem to change nicely. And then you can hit Cancel to back out without having those changes take effect, although it seems as though they did. Well, either way, if you hit Control-Z, the changes will reverse themselves, and you go back to what you originally had. Now let's finish up this geometry quick. You'll see that when you click Reference Line, it remembers the settings you used with the last line you drew, which is nice, a bit of a time saver. So you can skip straight to the Set Plane option, go to Pick a Plane, OK. This time we'll pick the middle plane, and again we'll go to Elevation North just so we can keep consistency. If you chose South the first time, you should choose South again. It really doesn't matter that much. Hit Escape to exit this line drawing tool. Go up to 3D view, and you'll see that that roof line drew nicely. It seems to be working well. We'll flex the parameters once the last line is drawn. So again, click on Reference. All the options are saved. Set a plane, pick a plane, this one. Go to Elevation North. And if you'll remember, the first plane we drew was up to here and down to here. We want this one to be the same so that as the first one, so it creates this fluid flowing motion between the roofs. And you'll see that those all worked quite nicely. I'm going to quick flex this geometry, make sure everything can update. It all seems to have jumped right into position. So I'll Control-Z and it'll go back to how it was. Now we're finally ready to move away from just lines and start creating form. To do this, we're not going to create the walls yet, because this conceptual massing environment is really only being used, at least I would only use it to create the structure and then the basic forms that I could bring into a Revit model to turn into something more meaningful, more architectural, if you will. So to create this roof form, I'm going to create a blend shape between the 3 roof lines at the top. One problem you'll see right away is if you click on this line, it will select every line in that chain. And that won't be ideal. It'll create some, well, let's just see what kind of form will that create. Not actually sure. It'll create this, which is pretty close to what we want to make, really. The only problem is that we don't want these walls. We just want the roof. So I'm going to hit Control-Z. This time, instead of just selecting the object, I'm going to mouse over it like this, then hit Tab. Tab cycles through the selection options that are currently available to your mouse's position. So it made it switch from selecting the entire chain to just one segment. And I'll do the same here. I haven't selected it yet, just hit Tab once, and now just that one segment is highlighted, so I know it'll select. And then I'll hold down Control, so I get this little plus key next to the pointer, which lets me know that it'll select multiple objects. Now I have those 2 selected. I'll do the same here. Click this Create Form button, and you'll see that it creates a nice, clean blend shape between them. It's important to note that this is a blend shape, not a loft. The two are very similar, but there are some subtle differences between lofting in Rhino and blend shapes in Revit. The most important thing to remember with blend shapes is that it's going to blend mostly just in one dimension. If you start making it curve, it doesn't really know what to do with the thing you're giving it. So try to keep it only varying in 2 dimensions and have one always perpendicular or always parallel, as with these vertical planes right here. Alright, so that being said, we now have this roof, which I want to use as a scaffold for beams. It's really the beams that I'm trying to create a parametric model of, not this generalized shape. So since this is nothing more than scaffolding, it's important to turn it into actually functional scaffolding. And a way to do this is to go up to this Divide Surface button, click it. You'll see that it instantly turns this surface into something that resembles a polygon mesh. It's not. It's actually a UV surface, much like any of the solid modeling tools in Rhino. And its UV grid is based on numbers that are given to it from this interface under the properties. If you ever accidentally close this, it can be re-accessed by this button right here. And these beams, I imagine them spanning just this way. So we only really need UV segments in one direction. Now, I've done this several times, so I know which one I need to get rid of. It's the V. So I'm just going to get rid of that. And you'll see that instantly these are looking a lot more like beams and a lot more like something we could use to position beam geometry. And then I'm going to go up here under Surface Representation, click this Display Properties button. You'll see that there are several options. You can pattern this surface and even give it family components, but we're going to keep it simple and just click Nodes. What this does is it creates a point which other geometry can snap to along the curve of this surface, which is going to be important because the next step in our process is to import geometry from another family. So let's get started on creating that other family. To create a new family, all you have to do is click on this R, go down to New, and click Family. Now, if you want a family to respond parametrically to changes in its placement or in the points where it was placed, it's important that it's not just a standard everyday family, because while you can create values that match up very nicely, it can become cumbersome, and if you have to, then it does work. But there's a better way to do it, which is to create special families specifically for this purpose, which are called adaptive families. And you can access them under this generic model adaptive right here. These use the exact same modeling interface as the conceptual mass environment with one slight difference, and an instant key that you can tell you're not in a standard family environment is again the gradient. The difference in this environment is that these origin planes, they don't define an origin. They just exist. If you try to create parameters between them and other objects, you'll find that the planes will also shift. So nothing in this document is solid. It's all very malleable. It'll change, and you have to be ready for that. But there is one thing which is constant, and those are the adaptive points. So to create an adaptive point, what I did here was I created just a reference point, so reference point on work plane, and I set this one. And then to make it adaptive, I'll click this button, and it instantly has these three work planes, X, Y, and Z work planes, oriented around it, and a number above it. The number corresponds to its placement order. When I go into my other family, which I'm going to just Alt-Tab over to, I'll click one of these nodes to place a beam, then the other, and the beam will snap into position. So to do that, I'll need two placement nodes, not just one. The order they're created does matter. This is 1, this is 2. And their orientation from one to another can matter, though in this case it won't. So the next step is to start creating some geometry between these. I don't want to use model lines because these do not parameterize well. So I'm going to use reference lines again. But an issue you'll find with reference lines is that they don't like to snap to the geometry that they're being associated with. They'll snap to it right away, but then you move that geometry and they're just left standing. And that was even when I was using this draw on face. What essentially happened was it associated the position of these with the points, but it didn't create any permanent relationship between the two. There is a way to get around this though, and that's to use this 3D snapping option. When you select 3D snapping, it allows you to create any of these shapes in the same way you otherwise normally would, but what it's actually making is one of these, a spline. Now what a spline is an interpolated curve between a bunch of points that can really be placed fairly arbitrarily to one another. It can become very organic, and it's very malleable. You just grab a point, move it, and the entire curve responds. Now, we don't want anything nearly this bendy, but the good news is that if you're drawing with reference lines that have 3D snapping activated, while they draw much like a spline, they'll associate like a spline. Their points will move with whatever they've snapped to. It'll still draw in lines, as you can see here. It still moves, except now they're straight lines instead of curvy, organic, curvilinear geometry. So we're going to draw a reference line using 3D snapping between these 2 points. One thing you may want to note about the reference line I used was the options that I had set up here. It was reference, align, but very importantly, it was also drawn on face. If it were drawn on work plane, it would associate with this work plane before it would associate with these points. And it could cause some strange things to happen down the line, which one of the biggest problems with this working environment, while it works wonderfully if you know exactly what you're doing and work concisely and cleanly the whole way through, if you make one mistake, it can set you back 10 to 15 steps. So it's very important to tread lightly and think through your moves. Like working in the shop, measure twice, cut once. Okay, so the next step along the way is to create points along this line with which we can start building geometry. Now, you may think to yourself, well, why don't we just build geometry that's associated with this reference plane right here? Or this reference plane right here. And the reason for that is when these start moving around, those reference planes rotate. And that can create some really weird deformations in the objects. And not only do the reference planes rotate, but when the, whoa, losing track of my selection there. When the work planes cross each other like this, it can create a phenomena known as gimbal lock, which will occasionally cause Revit to flip the normals, and it will create this bizarre twisting in the geometry. So to avoid that, we want to associate all the geometry only with the work planes of this line. So what I'm going to do to create said geometry is go back up here, create a reference line, point. It's going to be associated with a face, and then I'm going to set the work plane to this. It doesn't matter that much, but it might matter if you had the wrong work plane selected. Then I'm going to place 2 arbitrary points along this line. Alright. Now each of these points has a work plane associated with it, though it's not always visible. One thing I like to do with work planes like this is select them, then make their work plane permanently visible just so I can select it more easily in the future. So to do that, first select the point, go up to this Show Reference Planes under Graphics in the Properties menu, and click Always, and you'll see that it remains selected. Always. Alright, now it's time to get started actually creating some geometry on these points. So to do that, I'm going to create reference lines again. This time it's going to be a rectangle because I'm creating a beam, typical wood framing construction. I'm going to draw on the work plane because I'm going to be selecting this work plane hosted around the point. I'm going to set that work plane, but before I start drawing, there's one thing that would screw up everything if I don't do it right now. I need to uncheck 3D snapping. 3D snapping is one of the greatest and worst functions of Revit. It will make everything you draw worthless if you have it selected at the wrong time, but it can make everything work if you have it selected at the right time. So now we have this reference square around our reference line. And as you'll see, it is associated with that line. It moves when the line moves, which is good. So now we need to set up some parameters for it, because right now it's a pretty arbitrary shape. I just kind of guessed where its dimensions were. So I'm trying to do an equal dimension, but one thing you'll notice is that it's drawing these equals dimensions on this work plane. I don't really like that because it's going to be difficult to work with down the line. So I'm going to go back, click my align dimensions again. This time I'm going to set the work plane to the one that we're working on, and it should work perfectly. Yep. draw them up a bit. One thing you'll notice is these dimensions are huge, almost unworkable. So I'm going to go to this scale menu, and because we're not doing any documentation in this can be changed as much as you want, just to make the numbers seem the right size. So right now it's set at this. If you move up, the numbers get smaller. And now you'll see that they're a much more reasonable size. So we're going to try setting that equal, but you're going to see this issue. And this is something annoying that Revit does occasionally, where if things aren't set equal to each other right away, and you haven't performed a function like this in the file yet, it doesn't understand what you want to move, and it doesn't know how to actually make those things equal. So we're going to go to cancel, select these dimensions here, or no, rather we'll select each of these side dimensions one at a time, and I did that by hovering over the square then hitting tab. You'll see that this one dimension becomes malleable. I'll set it to 6 inches. I'll do that for the other side as well. And now they should be able to be equalized, right? Hopefully that worked for everyone else following along. Okay, this time I'm pretty sure it's going to work without me setting them equal to one another. Oh no, I'll have to go through and do it by hand once again. So I'll set this equal to 6 inches, this equal to 6 inches. Select these and equalize them. Now, before I even parameterize this, I want to check to make sure that it doesn't... Actually, no, that won't work. Let's parameterize it and see if this works. If it doesn't, I'm not exactly sure what's going on, but it really should because it's worked many times before. So let's see. Give this a parameter of height. Give this a parameter of width. Then we'll go into our parameters here. Make its width 3 inches and its height 8 inches. And hit OK. And it worked. You may have noticed there was a bit of hesitance in my voice when I was saying this was going to work. And that's because even when you know what's happening in Revit, it will still throw curveballs all the time. Everything it does is very logical, but it may not always seem that way. And it won't. So just bear with it and work through the frustration if you're ever trying to do something and it really isn't working. And usually you'll be rewarded by a quality product after all of the hard work. So I'm doing the exact same thing I did on the other end. This is a reference square, draw on work plane, and I set the work plane, and I made sure this was not checked because everything would go wrong if it were. I'm going to go to angle dimension, make them equal, and one thing you'll notice is while they aren't equal, this time when I select the equality button, they snap to being equal. Perfectly fine. And that's because Revit has seen me do it. At least I think it's because Revit has seen me do it over here. I've noticed this happens with some functions in other parts of these environments too. So I suspect that there's some hidden logic engine somewhere inside of this program that determines, oh, hey, that's what he wants to do, so I'll just do it that way. And that's why it doesn't get stuck. Alright, so rather than giving each of these new parameters, I'm going to use the parameters already established, which you'll see are conveniently located on this list with the Add Parameter button. So I will give this a width of 3 inches, which was established elsewhere. And then I will give this a height. And one weird thing you'll notice is that my dimensions kind of ended up on top of each other there. That makes them a little bit more logical. Alright, so now that we have these two parameterized dimensions, and they move quite nicely, with the moving adaptive points, we can create a form out of them. If you select two forms that are facing each other, as these are, and click the Create Form button, it will create an what I believe is an extrusion. It may also be a blend shape between the two. Again, one of the reasons why this all-powerful Create Form button here is not always the best is because you don't always know exactly what kind of shape you're making. But I know that this one works, and that's a good way to make it, is by having two curves parallel to one another. Alright, so one thing you'll notice now is that if we were to place these 2 points in our file, we would get a beam that was hovering in between on the structure. And you know, I'm just going to show you what that would look like right now so you can kind of see how it works. I'll save this. Actually, no need to save. Okay, so I'll click this point and then this point. And you'll see that its dimensions are perfectly fine. It expanded nicely, stretched across the expanse, but it still isn't coming out to the ends. However, the distances between the lines and the endpoints are much greater and are actually entirely proportionate to the distances here. And that is because of what drives these distances. You can find and edit this under the Dimensions tab of the reference point. So to do that, click on the plane, which is also linked to the reference point. Go down to Dimensions, and you'll see that its measurement type is a normalized curve parameter, which means that it defines its position from 0 to 1 along the curve it's placed on. And here's its normalized curve parameter number, which is 0.189918. If we just set that to 0, it will instantly snap to 0. Now, if you're wondering what defines 0 and 1, it's the beginning and end of the line. I started drawing the line on this point, ended drawing it here. You'll see that it measures from the beginning. If we go over to this one, it's measured from the beginning as well. Now, let's just measure it from the end for simplicity's sake. We could also have its number be 1 from the beginning, but 0 from the end is exactly the same as 1 from the beginning. And now you'll see that this beam will change and adapt to the placement points perfectly fine. So let's click Load into Family again, which is what brings it into this family environment. If there were more projects open, it would give you a drop-down list and you would select which ones you wanted to load it into. But this is the only family open, so it assumes that this is where you want it. And it gives you these options: overwrite existing and its parameters, or cancel. The difference between these two is if you change the beam from 3 by 5 in that last file to 10 by 10, clicking overwrite the existing version would change where the points were located along the line, but it would not change the new parameters you'd given it, whereas this one would. We didn't change the parameters, so we can just go with overwrite existing version, and you'll see that it instantly snaps into place. And now it moves to the beginning and the end of this line. One little caveat I'd like to mention quick: if these dark lines along a form are ever bothering you, you can type in the shortcut TL, and all line weights are set to their minimum. TL stands for thin lines. And I usually like working on this mode when a file gets busier because it can be hard to tell what's going on past all the line weights sometimes. Okay, so now you could go and access this family through this generic models family 2, click Create Instance, and put them in individually on each and every one of these beams. But that would be incredibly time consuming. So I'm going to undo that. Simply select this beam and then click this button up here, Repeat. What this does is it tries to understand a pattern in the placement of that piece of geometry, which was from this V coordinate to this V coordinate across the U coordinates. And because it was just one, it assumed that you wanted it on every one. If I placed two with a gap between, it would understand that as every other. It reads simple patterns like that, but it's not that smart, so don't try testing its intelligence to its limits. Or try it and be ready to have some issues. Okay, so looking at these ends here, you'll see that they look pretty nice. They bend normal to the curve, or they don't bend. They rotate normal to the curve so that the vertical normal of this beam is always perpendicular to the tangent of the curve at the point where it's placed. And that's great. However, on this side, it's not as great. You get some really funky bending moments in these beams, and it really would not be an ideal structural system. The reason it's doing this can be found inside of the family properties of these beams. So to get to that, I'm just going to switch back over to this file. And if you're wondering how I'm changing like this, I'm hitting Control Tab. It just switches which tab is open. Okay, so in this file, I am going to look at how it's being placed, because that's really what defines how it decides to interpret the placement points, is how each of these points is set to orient. So here you'll see that this one's set to host reference and this one is set to host reference. However, that means that this one will be normal to the curve it's placed on, and this one will be normal to the curve it's placed on, which is really not what you're seeing. You're not seeing bending in this. And the reason for that is because the line that's hosted off of this point and the one hidden underneath here, I don't think I can even select it, but the line that this beam is based on, its normals are set by its first placement point. So this is really the one that matters, but I always change them both just to be safe. Okay, so under orientation, you'll see that you have several options. Auto-calculate, I don't trust. It doesn't usually seem to do much good either. It usually defaults to host reference. Vertical on placement always works, but it can cause some issues if you try basing anything off of the geometry later. It's moderately destructive of a process of calculating. It can lose some things. Orthogonal on placement is usually my go-to first option. It doesn't always work in some circumstances and can be a bit wishy-washy. Sometimes it gets the job done, sometimes it doesn't seem to make any difference at all. It can even make it worse. But in this case, since it's a pretty simple situation, it should work. So set those to orthogonal, overwrite the existing versions, and now let's look at what we've placed. They seem to be placed quite nicely. Vertical on all sides. If you want to look into those placement options and specifically how they work, I would suggest looking through some Revit forums. There are a lot of very intelligent Revit modelers who write all the time about issues they've had and how they resolved them. It can be a little over my head sometimes, and it takes some digging into definitions and what they're actually trying to say. But it's pretty cool when you can actually understand them and see how this program works. Alright, so that being said, now we have this nice form. We can access its width, roof difference, and length through these parameters here. So let's say make it a bit longer, wider, and taller. And it instantly snaps to this new position. But now these beams are starting to feel kind of far apart. Fortunately, that is still something that can be very easily changed. To do so, select this outline here, which represents the surface that once existed. I'm pretty sure, yep, if you click this button right up here, you can make the surface visible again, but you don't actually want it visible. because it would detract from the lightweightness of these beams. Anyways, select it, and you'll see under the number in the U grid, you can change this, and it will change your parameters that the beam placement is based off of. That may be a bit too much, but rather than just changing it back, I want to do something else. It's a little inconvenient always clicking on these lines to change these things, so I'm going to parameterize the number of beams. And this is something very important to know about this interface. Any single one of these properties can be parameterized if it has one of these little ovals next to it. And all you which is the associate family parameter button. All you have to do is click that oval next to whatever you want to parameterize, click add parameter, then give it a name like number of beams, hit OK, and now you'll find up here under other there's a number of beams function. I'll set that to 35. The parameters we gave these are also not lost. They've been maintained under their type parameters, which you can get to just by selecting the beams, going up to Edit Type, and then changing the width and height in here. Well, this tutorial has already gone pretty long, so I think I'm going to end it with the roof structure here. Hopefully you learned a couple things watching this, and hopefully you're interested enough in this software to pursue it further, though it can be pretty tedious and painstaking when Rhino is available. All I'll have to say about this is that while this may not always seem the best suited for what we're doing right now in the academic environment, if you create a beam structure like this or something and really need it inside of a Revit document that has all the wall types and has all the really fine detailing which Revit can do, and you want to be able to change it potentially if your ideas change, these techniques are fairly invaluable, because moving beams around inside of the Revit project environment is incredibly tedious if you've ever tried doing it. This is fairly tedious too, but once you become somewhat familiar with the interface, you can create systems that are uniform but also varied, that can change very dynamically and adapt to changing concepts within the architectural work. Alright, well, thanks for watching, and hope you learned something.